On 6 March 1944, inside the briefing hall of the 8th Air Force headquarters in England, the day's operation was being assembled with the precision of an industrial process. Weather specialists dragged chalk across a massive board, sketching out the winds aloft and the cloud deck sweeping across Berlin. The objective was clear: strike the Reich Air Ministry, a mission already expected to meet fierce resistance before the first engines even started. Colonel Hubert Zemke, commander of one of the most formidable fighter groups in Europe, examined the operational map spread across the table before him. Once satisfied, he picked up the secure line to finalize fighter coverage. A total of 48 Republic P-47 Thunderbolts, drawn from the 56th Fighter Group's 61st and 62nd Fighter Squadrons, would ride shotgun for the bomber formations heading deep into Germany. No one in that room yet understood that this single sortie would become a defining example of how unmatched durability, combined with overwhelming firepower, could reshape the dynamics of air combat. The war over Europe had forced the U.S. Army Air Forces to rethink the role of fighters. They were no longer merely offensive instruments; they had become protective armor for the bomber streams. The Luftwaffe, recognizing this shift, had established dense defensive corridors manned by Jagdgeschwader 2, Jagdgeschwader 26, and other elite units, stretching from the Channel to the heart of the Reich. Veteran pilots flying Messerschmitt Bf-109s and Focke-Wulf FW-190s, many with years of combat behind them, waded along these routes to cut into any American force that ventured toward Berlin. Across the English airfields, P-47s accelerated off runways at roughly 350 miles per hour, the sheer bulk of each aircraft shoving aside more air than any other single-engine fighter of the era. At nearly 8 tons, the Thunderbolt was a flying fortress in its own right, built around armor, fuel protection, and brute mechanical strength. Lieutenant Robert S. Johnson, one of the 56th most experienced pilots, stood beside his machine inspecting the scars still visible from a previous encounter. His fighter was equipped with self-sealing tanks, armor sheeted behind the cockpit, and a weapons layout devised for destructive efficiency. 8.50 caliber Browning M2 machine guns, each delivering around 800 rounds per minute, and 5-inch high-velocity rockets slung under the wings and belly. At the center of the aircraft sat the feature that would secure the P-47's reputation, the Pratt Whitney R-2800 Double Wasp. Producing roughly 2,000 horsepower, the twin-row 18-cylinder radial engine displaced 155.7 cubic inches per cylinder and embodied the American design philosophy of rugged reliability. Whereas a single coolant leak could doom a liquid-cooled German inline engine, the R-2800 could absorb catastrophic damage, sometimes losing multiple cylinders, and still keep turning. The result was an aircraft with survival statistics that bordered on the unbelievable. While many wartime fighters suffered combat loss rates above 10% per mission, the Thunderbolt averaged a loss rate of only 0.7%. Major Gerald Johnson, the group's executive officer, had scrutinized these numbers repeatedly. A West Point graduate with a talent for mechanical reasoning, he understood that the decisive factor in air combat was the manipulation of energy, how altitude translated into velocity, how turn radius intersected with fire control, how predictive aiming separated a lethal burst from a wasted one. Meanwhile, inside Germany, preparations were underway with equal seriousness. In his FW-190A5, marked Black 3, Oberlieutenant Egon Meyer reviewed his ammunition configuration. His aircraft carried 2 MG-151-20 cannons with 250 rounds per gun, along with 2 MG-17 machine guns loaded with 1,000 rounds each. Meyer, credited with 102 victories, had refined precise combinations of armor-piercing and high-explosive ammunition to counter the heavily fortified American bombers. But intelligence had made it clear that the new escorts posed a different kind of problem. Reports describe the P-47 as an aircraft that could endure damage far beyond what German pilots were accustomed to inflicting. To bring one down, he would have to deliver sustained, accurate fire to critical spots. Meyer had pioneered the head-on attack technique for breaking apart B-17 formations, but even he understood that engaging the incoming Thunderbolts would require fresh calculations, new timing, and unbroken concentration. As both sides prepared for the inevitable confrontation that morning, neither yet grasped how dramatically this mission would showcase the evolving science and brutality of aerial warfare. Combat analysts of the air war had come to a stark conclusion after years of studying gun camera footage and after-action reports. A bomber struck head-on by 4 or 5 20mm rounds was usually finished, while attacks from other directions demanded roughly 4 times that number to bring down the same aircraft. These assessments, refined over 3 winters of operations, were generally reliable, except when applied to the P-47 Thunderbolt. That machine regularly returned home in conditions that contradicted every predictive model. Aircraft limped back with entire cylinders torn from radial engines, elevators shredded to ribbons, wings perforated by cannon fragments, and skin panels peppered by hundreds of small-caliber hits. On the morning in question, American fighter elements were converging above East Anglia as they did on every major mission. 3 squadrons shaped their assembly orbits while climbing toward escort height. Comparable formations, nicknamed George on the left and Rabbi on the right, took up their respective sectors, with the 56th Fighter Group rising steadily in the center of the pattern. In each Thunderbolt cockpit, pilots worked their Mark V sights and checked their harmonized .50 caliber guns, settling into the disciplined scanning rhythms drilled into them over months of combat. They paused every few degrees of heading to clear blind spots and study the horizon for condensation trails. The atmosphere above 25,000 feet guaranteed contrails. Temperatures hovered near -40 degrees Fahrenheit, and visibility was unusually sharp. At 0915 on March 6th, Johnson's element made the first visual detection. A group of 16 Focke-Wulf 190s was climbing from the east on a bearing of 090 degrees relative. Johnson keyed his transmitter and set his armament switches. His brief call, "Bandits, 3 o'clock high, 16 or more," cut across the formation. Inside the lead German aircraft, Meyer heard a clipped update from his ground controller, reporting an incoming American escort group approaching the bomber stream. He immediately ordered a steep climb to intercept. The BMW 801 radial surged as emergency boost and water methanol injection were engaged, forcing output past 2,100 horsepower. The FW-190s clawed upward at roughly 3,300 feet per minute. Reaching fighting altitude would take just under 5 minutes if undisturbed. Meanwhile, Executive Officer Gerald Johnson recalculated the geometry on a knee pad. He estimated the enemy's velocity around 350 miles per hour, which meant a closing speed of approximately 600 miles per hour. The Germans still held about 2,000 feet of altitude advantage. The Thunderbolt's turbo-supercharger reached peak efficiency near 30,000 feet, but the encounter would unfold closer to 27,000 feet, an altitude at which both aircraft types retained strong performance. The first shots of the day were fired at 0923. 8 P-47s executed a coordinated diving attack from around 29,000 feet, converting their height into speed. The big fighters plunged through 450 miles per hour as they swept down across the German formation. Tracer streaks, incendiary and armor-piercing, cut through the clear sky, but the initial burst found nothing. The FW-190s had rolled away at precisely the right instant, exploiting their exceptional lateral agility. Johnson adjusted his expectations. Their reaction time was quicker than earlier estimates suggested, closer to 2 seconds from visual contact to evasive maneuver. He ordered his flight to alter the approach vector and rehearse a second strike.
At 0931, the renewed attack run connected, placing several hits on the enemy formation and beginning the true air battle of the mission. Repeated bursts from 4 P-47 Thunderbolts raked the engine housing of a Fowler-Wolf fighter, smashing into the forward fuselage with concentrated fire. Thick, sooty smoke streamed from the impact point, yet the German pilot maintained command of his machine. Johnson noted that the propeller still rotated cleanly, evidence that the aircraft's control surfaces and power plant remained functional despite the punishment. The BMW 801 radial engine, long admired for its rugged construction, once again demonstrated a durability approaching that of the American Pratt Whitney R-2800. At 0935, the third attack run unfolded. Johnson had estimated the required lead at roughly 30 degrees, but high-altitude crosswinds subtly altered the trajectories of the 50-caliber rounds. His burst slid behind the target, missing by a narrow margin. At that instant, Meyer's wingman initiated a defensive barrel roll, exploiting the Fowler-Wolf's exceptional roll rate, approximately 160 degrees per second. It was a well-practiced maneuver, typical of Luftwaffe pilots who had spent years refining escape tactics during the air defense struggle over Europe.
The fourth assault finally produced results. Lieutenant Walter Beckham intercepted a German fighter as it attempted a climbing turn. Beckham fired a focused 3-second burst, unleashing around 400 .5 caliber rounds. The concentrated fire severed the structural integrity of the enemy's wing root, causing the aircraft to snap into an unrecoverable spin. No parachute emerged from the tumbling wreck. At 0942, Mia directed his formation into a head-on pass against Johnson's unit. Their combined closing speed exceeded 600 miles per hour, leaving less than 2 seconds within effective firing range. Both sides opened fire at roughly 800 yards. The sky filled with intersecting tracer lines. Johnson's Thunderbolt jolted as 20mm shells slammed into it, 3 striking the forward engine area, 2 penetrating the starboard wing, and another hitting the tail assembly. Oil pressure began to fall while cylinder temperatures climbed rapidly. Even so, the R-2800 Double Wasp, famously over-engineered, continued functioning. Although 2 cylinders lost compression, the remaining 16 maintained enough power to keep the aircraft airborne. Oil streamed from damaged lines, but redundant pressure systems compensated. The turbocharger, protected by armor plating deep within the rear fuselage, survived intact. Johnson throttled back to 75% power and initiated the return flight. 20 minutes later, he brought the battered fighter down at Haleworth. Maintenance crews later counted 43 bullet perforations and 5 cannon impacts. Despite the extensive damage, the aircraft was slated to be fully serviceable again after only 2 days of repairs. Johnson himself was unharmed. The engagement underscored the guiding principles behind the Thunderbolt's design philosophy: survivability through system redundancy, combat strength derived from excess engine capacity, and victory achieved through mechanical resilience. Yet the strategic lessons of the encounter were only beginning to reveal their significance. On 26 June 1943, the 56th Fighter Group met a contingent of Jägerschwader 26 aircraft over France, 48 P-47s against 16 Focke-Wulfs. Numerical superiority appeared to favor the Americans, but the German pilots held key advantages: tactical positioning, combat experience, and the element of initiative. What followed became one of the most cited examples of the Thunderbolt's near-legendary ability to withstand punishment. Lieutenant Robert Johnson flew in the most exposed slot of the 61st Squadron formation, the tail-end Charlie position, often assigned to younger pilots as part of their operational training. His aircraft, a P-47 C-2E designated serial number 416235 and nicknamed Half Pint, carried the standard 8.5 caliber Browning machine guns, each loaded with 350 rounds. The formation maintained altitude around 26,000 feet as it approached the region near Forges-les-Eaux.
The first warning of imminent danger arrived not from radio calls or visual sightings, but from the sudden detonation of incoming rounds. German fighters had begun their attack. The first moments of the attack were catastrophic. In less than 2 seconds, a stream of 20mm cannon rounds tore straight through Johnson's Thunderbolt, shredding the forward fuselage. The blast from the impacts blew apart the flight instruments, and the canopy fractured into jagged fragments. A mist of hydraulic fluid swept across the cockpit, coating every surface. One fragment from a cannon shell slashed the bridge of Johnson's nose, leaving him dazed and bleeding. Additional gunfire ruptured the oxygen lines behind the panel, and flames began to flare near the engine cowling where fuel sprayed freely from damaged conduits. The P-47 flipped inverted almost instantly and wound itself into a tightening spin. Johnson was crushed sideways against the canopy by the rotational forces, unable to lift himself from the seat. The altimeter, one of the few gauges still readable, unwound rapidly, 20,000 feet, 15,000, 10,000. He attempted the textbook spin recovery inputs, rudder against the rotation, nose forward, wings leveled, but the aircraft ignored every command. The fire along the fuselage expanded, reaching the ammunition compartments in the wings. Individual rounds began exploding from the heat, adding sharp concussive pops to the roar of the slipstream. At approximately 4,000 feet, the situation shifted. The flames died abruptly, likely due to lack of fuel or reduced oxygen at the lower altitude. The spin eased, and Johnson regained a thin margin of control authority. But escape was impossible. The canopy release system had been completely disabled by cannon hits, and portions of the plexiglass canopy had warped from heat, locking him inside. The engine, running on what seemed to be an uneven handful of surviving cylinders, coughed continuously, yet kept producing enough thrust to keep the aircraft aloft. Oil covered the front windscreen in an opaque sheet, eliminating any forward view. Johnson could only see faint slivers of the outside world through broken sections of the side panels. His compass had been destroyed along with the rest of the dashboard, leaving him to navigate purely by dead reckoning and the position of the sun. He headed west, hoping to reach the English Channel. His actual altitude was roughly 1,000 feet, but with all the instruments ruined, this estimate was partly intuition. Airspeed was unknown. He suspected he was barely above stall, but every remaining gauge that could have confirmed it had been shot to pieces. Fuel was streaming from multiple holes in the wings, though he had no clear sense of how much remained. Reaching British territory meant crossing nearly 50 miles of hostile coastline lined with anti-aircraft guns and several Luftwaffe fields, including those at Abbeville and Poix. Then came the worst development. Approaching from the rear was a single Focke-Wulf 190, recognizable by its vivid blue and yellow nose, markings typically associated with experienced German pilots. Johnson had no means of defense. The gun sight was obliterated, and with the hydraulics gone, he could not charge or operate his own weapons even if the gun mechanisms had survived. The Thunderbolt, limping along at an approximate speed of 200 miles per hour, presented an easy target. The German fighter slid neatly into firing position and opened up at roughly 300 yards. A new storm of machine gun fire struck the P-47. Johnson heard the impacts as an almost continuous metallic howl. Bullets smacked into the rear armor plate, producing heavy, bell-like reverberations behind his head. More rounds shredded the remaining fabric surfaces and sliced into the control cables, further degrading the aircraft's responsiveness. Whatever was left of the instrument panel disintegrated into fragments under the renewed.
Johnson bent forward as far as he could, trying to shelter behind the seat armor. According to later accounts, some naming the attacker as Egon Mayer, though historians have debated this identification, the German pilot delivered short, disciplined bursts, the kind characteristic of a seasoned expert. His cannon ammunition had apparently been spent earlier, leaving him with only the machine guns, but even these were more than enough to continue dismantling the already ruined Thunderbolt piece by piece. For close to 3 minutes, the German fighter shadowed the damaged P-47 and delivered measured bursts of gunfire. The attacks were deliberate rather than frantic, short strings meant to stretch his remaining ammunition, each one directed at vital systems, the engine section, the wing roots, the control linkages, and the fuel tanks. Yet the Thunderbolt, already battered, refused to fall out of the sky. Its R-2800 engine,
running on only 14 functioning cylinders, continued producing enough power to keep the aircraft airborne. Even the control surfaces, torn and perforated in dozens of places, still responded to Johnson's inputs. The self-sealing tanks bled fuel, but did not rupture. Eventually, the German pilot eased his FW-190 alongside the stricken American fighter. Through what remained of the canopy, webbed with cracks and smeared with oil, Johnson could make out the enemy pilot studying the P-47's condition. The German's expression suggested disbelief. The Thunderbolt had taken far more damage than any aircraft should reasonably survive. The FW-190 dropped behind once more and resumed its attack. Additional rounds raked across the P-47's wings, fuselage, and tail. The elevator trim tabs were shot off entirely. The rudder was repeatedly struck. The ailerons were pierced by yet more rounds. Even so, the aircraft continued to remain controllable. When the German pilot formed up beside Johnson again, it appeared that he had either expended his ammunition or simply abandoned the attempt to bring the American fighter down. He met Johnson's gaze, rocked his wings, perhaps a gesture of respect, and then turned back toward the French coast. Johnson continued on alone across the channel, flying at barely 500 feet. The engine was losing power steadily, running rougher with each minute. What little oil remained coated the windscreen so heavily that forward visibility was almost gone. Instruments and radio had failed completely. Ahead, the English shoreline came into view through streaks of oil and smoke. RAF Manston sat roughly 10 miles inland, and Johnson aimed for it with what control authority he had left. He had no means to declare an emergency. He simply approached at treetop height, hoping the ground crews would recognize that the aircraft was on the verge of failing. The touchdown that followed was essentially a crash that happened to occur on a runway. The flaps were useless, hydraulics had been destroyed, and the brakes were gone for the same reason. The emergency system had forced the landing gear down and locked, and by some fortune, they held. The Thunderbolt rolled the full length of the field and only stopped as it ran out of momentum.
Rescue crews rushed in immediately. They were unable to open the canopy. Cannon hits had warped the frame and had to hack through the plexiglass with axes. Johnson emerged drenched in hydraulic fluid and oil, cut in several places but still able to stand. When he tried to count the bullet strikes along the fuselage, he gave up after reaching 200 on just one side. A later survey documented at least 21 impacts from 20mm cannon rounds in addition to the hundreds of machine gun holes. One cannon shell had passed directly through the armor plate behind Johnson's seat without exploding, leaving a clean hole where detonation would have killed him instantly. The aircraft, nicknamed Half Pint, was declared a total loss. 4 days later, Johnson returned to flying operations in a new P-47. He ultimately achieved 27 confirmed victories in the air, placing him among the most successful American fighter races operating in the European theater. Yet it was his survival on 26 June 1943 that became a defining legend within P-47 circles. That episode was repeatedly cited by Thunderbolt pilots as proof that their machine could endure levels of punishment that defied logic and still carry its pilot back across the channel. The psychological repercussions were felt well beyond Allied units. German flyers grew increasingly anxious as reports circulated of American fighters that seemed able to soak up extraordinary damage. Allied intelligence monitoring German transmissions noted a steady rise in such comments. In several Luftwaffe accounts, the term Betonflugzeug, literally concrete aircraft, began appearing in operational notes, reflecting the belief that the P-47 was nearly impossible to destroy. In response, Luftwaffe training directives were quietly amended. New guidance instructed pilots to avoid wasteful engagements and instead to strike Thunderbolts with concentrated bursts of 20mm cannon fire pointed at a handful of vulnerable locations: the turbo supercharger intake, the oil cooling system, and the cockpit region.
Even then, the effectiveness of these tactics proved inconsistent.
Examples from the summer and fall of 1943 illustrated the dilemma. Captain Fred Christensen of the 62nd Fighter Squadron returned on 29 July with his aircraft pierced by 47 bullets and 6 20mm impacts. On 17 August, Lieutenant Ralph Johnson managed to fly home despite an entire cylinder being torn off his radial engine. A similar incident occurred on 4 October, when Captain Walker Mahurin landed a Thunderbolt that looked as if it had been riddled like a sieve. It required 6 weeks of work before it was declared fit to fly again. The 56th Fighter Group's engineering officer, Captain Barney Wazowicz, compiled detailed assessments of the damage. He found that most incoming fire clustered around the engine and cockpit, areas German pilots believed were most sensitive. Yet the Pratt Whitney R-2800 repeatedly demonstrated that it could continue running with as many as 3 cylinders completely incapacitated. When oil was lost, pilots could still maintain flight by reducing throttle settings and maximizing airflow for cooling. The rear-mounted turbo supercharger, a distinctive feature of the P-47, benefited from being shielded by armor and the surrounding fuel tanks. The only hits that consistently destroyed Thunderbolts were those from 30mm cannon shells, a weapon carried by relatively few German fighters. The resulting calculus of survivability strongly favored the Americans. By the end of December 1943, the 56th Fighter Group had completed 5,847 operational sorties. Only 56 aircraft had been lost to direct enemy action, and 34 pilots had been killed. This amounted to a loss rate of roughly 0.96% per mission. In stark contrast, German fighter units engaging American bombers often endured attrition rates exceeding 15% on a single operation, a disparity that eroded their operational capacity at an unsustainable pace. Technical analysis clarified the reasons behind the Thunderbolt's remarkable durability. The R-2800's 2-row, 18-cylinder arrangement offered substantial redundancy, supported by dual magnetos and separate oil systems that ensured the engine could continue producing partial power even when heavily damaged. Its broad radial design created aerodynamic drag, but it also acted as a massive protective barrier for the pilot. Any projectile aimed at the cockpit first had to pass through a large mass of metal. The P-47's airframe was built to survive extreme stresses. Its wing spars were engineered to withstand loads approaching 12 Gs, and its control run architecture included redundant cables and emergency mechanisms. Fuel tanks were surrounded by self-sealing materials and armor plating, and the ammunition storage areas were sited to minimize the risk of chain reaction explosions. Each major system reflected the same design philosophy: assume battle damage and ensure the aircraft can still return home. Republic Aviation's facilities in Farmingdale, Long Island, scaled production to extraordinary levels. At peak output, the factory delivered 16 Thunderbolts per day. Total production ultimately reached 15,683 aircraft, more than any other American fighter of the war. The combination of engineering resilience, industrial capacity, and combat performance cemented the P-47's reputation as one of the most durable fighters of the Second World War. Industrial capacity in the United States gradually overwhelmed Germany's ability to resist in the air. By the time American fighters were committed in large numbers, the loss of a single P-47 Thunderbolt hardly registered. Any aircraft destroyed in combat was replaced many times over, and fresh pilots emerged from training pipelines at a pace that exceeded battlefield attrition. As the spring of 1944 approached, P-47 units operating over Western Europe possessed such numerical and operational dominance that the Luftwaffe struggled to mount effective challenges. Combat reports from this period show a kill ratio of roughly 4.6 to 1 in favor of U.S. fighter pilots. Yet the most decisive achievement was not the tally of downed enemy aircraft.
It was the transformation of bomber survival rates. Before long-range escorts became standard, American heavy bombers routinely suffered losses exceeding 10% on a single mission, a level considered strategically unsustainable. Once Thunderbolts began flying escort in strength, the rate dropped to under 2%, an arithmetic shift that ultimately spared thousands of aircrew who might otherwise have been lost. Major General William Kepner, who commanded 8th Fighter Command, emphasized that the Thunderbolt introduced a new philosophy, the idea that an aircraft's capacity to withstand damage was as crucial to success as raw performance. Pilots who understood that their machine could absorb punishment far beyond that of earlier designs tended to take calculated risks and fight with heightened boldness. The psychological effect, though difficult to quantify, was widely acknowledged by commanders and aviators alike. German perspectives from the period echo the American assessment. General Adolf Galland later wrote that the P-47 behaved like an armored brawler in the sky, a flying tank, as he phrased it. Luftwaffe pilots quickly learned to avoid lingering engagements with Thunderbolts unless they held a clear tactical advantage. Numerous German accounts complained that American fighters continued to fly and even fight after sustaining hits that would instantly cripple or destroy most German aircraft. These mechanical realities shaped the evolution of Allied tactics. Colonel Hubbard Zemke devised what became known as the Zemke fan, a flexible escort method designed around the P-47's resilience. Instead of remaining close to the bomber formations, Thunderbolt squadrons dispersed ahead, above, and to the sides of the bomber stream. This allowed them to disrupt German fighter concentrations before they could attack en masse. The approach demanded aircraft that could operate independently for extended periods and still return home despite damage, conditions for which the P-47 was uniquely suited. The method proved its worth on 11 February 1944. That day, the 56th Fighter Group, operating ahead of the bomber route, encountered roughly 60 German aircraft assembling for an interception. The ensuing engagement resulted in 17 German fighters claimed destroyed at the cost of only 2 P-47s. Several Thunderbolts limped back to base carrying damage that would have been fatal to lighter fighters. One aircraft flown by Lieutenant Roach returned despite losing its entire left elevator. Another flown by Captain Francis Gabby Grabeski landed with severe engine damage, including multiple cannon shell perforations in the cowling and only a portion of its cylinders still functioning.
Grabeski, who eventually became the highest-scoring American ace in the European theater with 28 confirmed victories, all achieved in P-47s, repeatedly demonstrated the toughness of the aircraft. In November 1943, a 20mm round detonated inside his turbo supercharger at 30,000 feet, eliminating his boost pressure. Despite the failure, he managed to glide more than 80 miles toward friendly territory, his R-2800 engine delivering just enough residual power to avoid capture. Low-altitude missions revealed yet another aspect of the Thunderbolt's durability. Ground attack sorties exposed pilots to dense anti-aircraft fire, rapid-firing 20 and 37mm guns capable of putting well over 100 rounds per minute into the air, and heavy 88mm batteries timed to burst at precise altitudes. Statistically, survival seemed improbable. Nonetheless, P-47 units routinely returned from close support missions that would have been prohibitively dangerous for more fragile aircraft. During the Battle of the Bulge on 23 December 1944, the 56th Fighter Group operated in weather conditions that grounded most Allied air assets. Visibility was under a mile, and cloud ceilings hovered only a few hundred feet above the ground. Even so, Thunderbolt pilots pressed forward, conducting near ground-level attacks against German armor and vehicle columns. Despite the oppressive weather and intense fire from below, many damaged aircraft managed to struggle back to their airfields, yet another demonstration of the Thunderbolt's remarkable capacity to endure punishment. Captain Robert Brooking once brought his Thunderbolt home after it had been riddled with dozens of small arms and automatic weapon impacts, 87 in total. By the time he reached friendly lines, several cylinders were gone, oil sheeted out across the cowling, and the controls answered only sluggishly. Yet the aircraft was patched up and flying sorties again within 3 days, an outcome that became almost routine within the 9th Air Force, the American command that oversaw tactical operations in Western Europe. During the period from D-Day on 6 June 1944 to VE Day on 8 May 1945, P-47 Thunderbolts executed roughly 135,000 attack missions against German ground forces. In that span, 4,293 aircraft sustained combat damage, and 824 were lost completely. These figures produced an extraordinary metric, an 80.8% survival rate for pilots in aircraft hit by enemy fire. No other Allied aircraft in the tactical strike role approached this level of battlefield endurance. A vivid example came on 1 January 1945. Lieutenant Colonel William Kennard, while attacking a German train, struck high-voltage lines strung across the landscape. The collision bent his propeller blades, crushed the engine cowling, and destroyed the oil cooling system. Even with the engine overheating to the point of imminent failure, Kennard coaxed the damaged machine over 40 miles of hostile territory and landed just before the power plant ceased entirely. A new engine was installed, and the fighter was back in action less than a week later.
The cumulative result of such ruggedness was catastrophic for German logistics. Over the entire campaign, Thunderbolts were credited with destroying 86,000 railway cars, 9,000 locomotives, 6,000 armored vehicles, and 68,000 trucks. The German transportation network, critical to reinforcing and supplying frontline units, was gradually strangled, not solely by high-altitude bombing, but by low-level P-47 strikes delivered through fire so heavy that more delicate aircraft would likely have been lost before releasing their ordnance. In the Pacific, the challenges differed but produced similar demonstrations of resilience. Based out of the Philippines and other captured fields, P-47 units faced Japanese anti-aircraft fire and fighter defense while also contending with vast stretches of open water. A single engine failure meant a forced ditching in seas known for sharks and swift currents. Despite these conditions, Thunderbolts posted the lowest loss rate of any U.S. fighter in the theater, a statistic largely credited to the near-bulletproof reliability of the Pratt Whitney R-2800 engine, even after suffering combat damage. Colonel Neil Kirby, commander of the 348th Fighter Group, showcased the aircraft's combat potential early in the campaign. On 11 October 1943, leading a flight of only 4 Thunderbolts, he encountered a formation of 36 Japanese fighters. In the chaotic fight that followed, Kirby scored 6 victories personally. His own aircraft absorbed repeated hits from 7.7mm and 12.7mm guns but remained fully controllable. Kirby accumulated 22 aerial victories before being shot down on 5 March 1944, overwhelmed not by the quality of the opposition but by sheer numbers. Japanese pilots, confronting the Thunderbolt's mass and stubborn durability, dubbed it the Monster. Their training manuals eventually advised avoiding engagements with P-47s unless they held overwhelming numerical superiority, as brief firing passes rarely inflicted decisive damage, while prolonged engagements left them vulnerable to the P-47's heavy armament. Behind these frontline stories stood an industrial machine unmatched by any Axis nation. Republic Aviation's massive Farmingdale plant stretched across 2.5 million square feet and employed nearly 24,000 workers at its wartime peak. A second facility in Evansville, Indiana, further boosted production. Together, they produced more Thunderbolts than the entire German aircraft industry could produce fighters of all types. The math revealed an industrial imbalance that Germany could not hope to redress.
Financial considerations reached a similar conclusion. A P-47D cost about $85,000 in 1944 dollars, and the training pipeline for a pilot represented an additional investment of roughly $75,000. If the aircraft's survivability saved even a single aviator from death or captivity, the combined cost of $160,000 was well justified. Over the course of the war, the Thunderbolt's structural toughness undoubtedly kept hundreds of American pilots alive who might have perished in more fragile fighters. The 56th Fighter Group, operating exclusively with P-47s despite intense pressure to convert to P-51 Mustangs, ended the war as the leading American air-to-air unit in Europe, with 677.5 confirmed victories. Its commander, Colonel David Schilling, summarized the group's unwavering commitment. "We stayed with the Thunderbolt because our pilots had absolute faith in it. They believed, and rightly, that it would bring them home no matter what it had endured."
Stories of survival became part of the aircraft's legend. One notable account occurred on 8 February 1944 when Lieutenant Quint Brown's Thunderbolt collided with a Focke-Wulf 190 during combat. What followed only deepened the reputation of an aircraft that, again and again, proved able to withstand punishment that would have destroyed almost any other fighter of its era. Roughly 3 feet of the aircraft's right wing were shorn off in the impact. The nose covering around the engine had been crushed inward, and the propeller blades were visibly distorted. Despite this severe damage, Brown managed to guide the crippled fighter for nearly 200 miles back to base, bringing it down safely. The airframe was subsequently rebuilt and returned to operational status. The German aviator involved in the collision did not survive. Captain Johnson McGinn experienced an even more extraordinary incident on 24 March 1945, when an 88mm anti-aircraft round punched straight through the starboard wing of his Thunderbolt without exploding. The projectile left an opening wide enough for a person to crawl through. McGinn nonetheless flew the aircraft home, observers recalling that the wing flexed dramatically with every control input. Republic Aviation's engineers later examined the damage and were astonished that the wing structure had remained intact. Their analysis suggested that most contemporary fighters would likely have broken apart under such conditions. Insights from these investigations carried into post-war engineering, influencing the development of the A-10 Thunderbolt II in the 1970s. The A-10's emphasis on survivability, including redundant hydraulics, armored protection for critical systems, and elevated engine placement to reduce vulnerability to ground fire, was a direct continuation of lessons first learned from P-47 combat experience. Pilot recollections consistently underscored deep trust in the Thunderbolt's resilience. Lieutenant Colonel Robert Basler remarked that flying the P-47 meant never doubting the machine's ability to withstand failures or damage. Whether dealing with engine trouble, holes in the airframe, or systems shot away, the aircraft continued to operate reliably. According to Basler, this mechanical dependability freed pilots to concentrate on combat rather than worrying if their fighter would keep them alive. German wartime accounts often echoed a very different sentiment. Luftwaffe ace Heinz Baer, credited with 220 victories, described the P-47 as one of the most exasperating adversaries they faced. He recalled firing bursts that should have destroyed any normal fighter, only to watch the American machine continue flying, even while pieces were seen breaking off or flames trailed behind it. To German pilots, the Thunderbolt's ability to absorb punishment and still fight back seemed almost inexplicable. Ground crews offered another perspective on the aircraft's ruggedness. Sergeant Anthony Garzino, who maintained Thunderbolts throughout the European theater, recounted seeing fighters return with levels of destruction that appeared irreparable. Cylinders blown out of the engine block, oil systems severed, control cables held together by only a few strands. Yet the maintenance teams routinely worked through the night, and many of those damaged aircraft were airborne again the following morning. Garzino emphasized that the Thunderbolt had been engineered not merely for combat performance, but for rapid repair and continued service.
Maintenance logs from the 56th Fighter Group provide quantitative support for these experiences. According to the records, nearly 3/4, 73% of damaged P-47s were repaired and returned to flying condition within 3 days. Major structural repairs typically took less than 2 weeks. Only aircraft destroyed outright or lost behind enemy lines were permanently removed from the unit's strength. For the era, such turnaround rates were unmatched. The logistics network that sustained P-47 operations reflected the industrial scale of the war. Pratt Whitney manufactured approximately 125,000 R-2800 engines, each containing more than 2,800 components. Replacement engines and spare parts moved across the Atlantic with remarkable speed. A Thunderbolt damaged in Britain could receive parts produced in Connecticut in a matter of 10 days. Ammunition supply demonstrated similar magnitude. Fully loaded, the P-47 carried 3,400 rounds of .50 caliber ammunition, and the 56th Fighter Group alone fired more than 10 million rounds during its wartime operations. Every cartridge required production, transport, and manual loading, highlighting the immense logistical operation behind frontline sorties. Beyond statistics and mechanical achievements lay the human significance of the Thunderbolt's durability. Each instance where the aircraft absorbed damage and remained airborne represented a life preserved, pilots who returned to their squadrons instead of being lost in combat. Multiplied across thousands of missions, the P-47's sturdiness translated into countless families reunited with loved ones after the war. Its legacy, therefore, extends not only through engineering advancements, but through the many lives saved by its exceptional ability to endure the harshest conditions of aerial warfare. Lieutenant Colonel Francis "Gabby" Gabreski, recognized as the highest-scoring ace to fly the P-47 Thunderbolt, later reflected on what the aircraft meant to the men who relied on it. In his view, the machine granted American pilots a rare certainty. They could commit to battles against larger enemy formations, strike targets protected by dense anti-aircraft fire, and continue their attacks even after sustaining damage. The Thunderbolt, he said, earned the trust of its pilots, and that shared confidence between airmen and their rugged fighter contributed decisively to the Allied victory in the skies. The operational record supported his assessment. Of the 15,683 Thunderbolts built, 3,499 were lost to all wartime causes. Across 746,000 sorties, the aircraft achieved an aerial victory ratio of roughly 4.6 to 1 and maintained an average loss rate of only 0.7% per mission. Behind those abstract figures was a transformative reality. The P-47's extraordinary ability to survive punishment fundamentally reshaped how aerial warfare was calculated. By the conflict's closing months, German aircrews had grown cautious of engaging Thunderbolts. The Luftwaffe training instructions issued in early 1945 advised pilots to avoid confronting P-47 formations unless they enjoyed clear tactical advantages and greatly superior numbers. If contact could not be prevented, doctrine recommended aiming for the oil cooling system or the turbo supercharger intake, since isolated hits elsewhere rarely disabled the aircraft. The notes admitted, almost begrudgingly, that the American fighter endured levels of structural damage that would have destroyed any German machine of the period. The legacy of the P-47 extended far beyond its combat tally. Its design philosophy demonstrated, more convincingly than any aircraft before it, that building a fighter around pilot protection and system resilience did not have to come at the cost of combat capability. Before the Thunderbolt's arrival, most nations prioritized speed, maneuverability, and engine performance above day-to-day survivability. The P-47 proved that an aircraft engineered to keep its pilot alive could still dominate in offensive roles, a lesson that shaped post-war military aircraft development. Internal engineering reports from Republic Aviation revealed how deliberately this durability was created. Structural members were manufactured with margins far above typical specifications. The wing carried spars stressed for loads reaching 12 Gs, at a time when 9 Gs was generally considered more than adequate. Control runs used cables thicker than contemporary requirements, and essential fluid lines were routed through shielded pathways to reduce vulnerability. Even the engine mounts were reinforced with crash survival in mind. The Thunderbolt's considerable mass, which critics initially viewed as a flaw, allowed engineers to integrate armor, redundancy, and additional structural bracing without compromising the airframe's stability. The aircraft's large radial engine, dominating the nose of the fuselage, acted as a formidable barrier during frontal engagements. The wide-set landing gear made the fighter resilient during hard landings or operations from rough forward bases. Features that looked like inconveniences became, in practice, core strengths. Combat doctrine evolved to make full use of these qualities. Pilots adopted attack profiles beginning with high-altitude dives, exploiting the P-47's remarkable capacity to exceed 500 miles per hour in a controlled descent. After striking their target, they converted that speed into altitude through steep zoom climbs. Thunderbolt pilots frequently initiated head-on attacks as well, trusting the massive R-2800 engine to absorb damage that would cripple other fighters. These aggressive methods only worked because the aircraft could withstand intense aerodynamic stress and enemy fire. This story of resilience mirrored the story of the factory that produced the aircraft. Republic Aviation transformed rapidly from a modest operation manufacturing a few dozen airplanes a month in 1941 to a major wartime producer capable of turning out 500 aircraft per month by 1944. The workforce surged from 3,000 to 24,000 employees, men and women whose craftsmanship carried life or death significance. Quality assurance at Republic became a point of pride. Every R-2800 engine was subjected to an 8-hour test run before installation. Every completed airframe underwent a flight test before acceptance. Manufacturing imperfections that might compromise combat performance were eliminated with strict rigor. Signs placed throughout the assembly halls reminded workers that an aviator's survival depended directly on their attention to detail.
The process required rapid learning. Early P-47B models experienced a series of issues, including engine instability, electrical and radio malfunctions, and canopy problems. Each defect was isolated, analyzed, and systematically corrected. By the time the P-47D series entered widespread use, especially the D-25 and later variants, the fighter had become significantly more reliable. Improvements were driven by detailed analysis of aircraft that returned home with battle scars, allowing engineers to refine armor placement, strengthen components, and adjust system routing in response to real combat damage. Training programs for pilots shifted as well. The Thunderbolt demanded techniques unlike those used in lighter fighters. Managing energy, maintaining speed, avoiding unnecessary turns, and exploiting vertical maneuvering became the hallmark of successful P-47 combat flying. Pilots learned to trust the aircraft's power, its ability to dive safely at high speeds, and its capacity to endure damage while pressing an attack. By the end of the war, the Thunderbolt had not only carved out an extraordinary combat record, but had also reshaped expectations of what a frontline fighter could be. It stood as evidence that survivability could be engineered, not merely hoped for, and that an aircraft designed with that principle in mind could decisively alter the course of an air campaign. From the early wartime training centers scattered from Bradley Field in Connecticut down to Millville in New Jersey, a new generation of pilots emerged who understood how to exploit every advantage of the P-47 Thunderbolt. These bases developed a curriculum that emphasized not only aerial marksmanship and formation tactics, but also the unique ways in which the P-47's rugged design could be turned into a decisive battlefield asset. The contrast between American and German aircraft became unmistakable as the war progressed. The Messerschmitt Bf-109, relying on a liquid-cooled power plant, could be rendered helpless by even a minor breach in its cooling system. The Focke-Wulf FW-190, though tougher thanks to its BMW 801 radial engine, still remained susceptible to oil system failures that often proved fatal. Neither German design possessed the layered armor, redundant internal systems, or sheer structural resilience that characterized the P-47. Luftwaffe pilots entered combat acutely aware that any significant damage to their machines could result in either a fatal crash or forced descent into enemy territory. Allied intelligence units noted a psychological shift among German aircrews. Intercepted messages and debriefed prisoner accounts described mounting anxiety when facing large Thunderbolt formations. Reports circulated within the Luftwaffe, claiming that pilots had witnessed P-47s, aircraft they believed destroyed, flying steadily home, while German fighters succumbed to a single burst of .50 caliber machine gun fire. German medical personnel even coined an informal term, Thunderbolt fever, for pilots who displayed stress symptoms after repeated encounters with the American fighter.
The Pacific Theater offered another proving ground. There, survival often depended on whether an engine could keep running over hundreds of miles of water. The Pratt Whitney R-2800, heart of the P-47 as well as the F-6F Hellcat and F-4U Corsair, earned a reputation for continuing to function even with severe battle damage. Naval aviators frequently credited this reliability with saving crews who otherwise would have been lost far from the nearest friendly runway. Maintenance teams became experts at improvisation. In frontline conditions, they carried out repairs that would have required specialized factory equipment on other aircraft, replacing individual cylinders on makeshift workbenches, reconstructing damaged control surfaces from salvaged components, and performing extensive engine work while under threat of attack. The Thunderbolt's engineering emphasized accessibility, allowing mechanics to return heavily damaged fighters to service far more quickly than comparable aircraft. Republic Aviation's supply network introduced logistical innovations that later influenced the entire aviation industry. A standardized parts numbering system allowed every component to be cataloged and monitored with unusual precision. High-demand items were strategically stockpiled at advanced bases so that maintenance delays were minimized. As a result, frontline Thunderbolt units routinely maintained aircraft readiness rates above 80%. A figure remarkable for aircraft engaged in non-stop combat operations. Combat photography reinforced the aircraft's reputation. Gun camera film regularly showed Thunderbolts enduring sustained cannon strikes, yet remaining controllable. Post-mission inspection teams photographed fighters with shredded wings, punctured fuselages, and engines missing entire cylinders, machines that by all logic should not have remained airborne. Each returning aircraft preserved not only the physical airframe, but also the invaluable experience of its pilot. In a conflict where veteran aviators became progressively rarer, their survival had strategic significance. The Luftwaffe, by contrast, saw its pool of skilled pilots dwindle. With each loss, German units became increasingly dependent on inadequately trained replacements, weakening their combat performance and accelerating the decline of their air arm. Weather operations further highlighted the Thunderbolt's strengths. Its robust structure allowed it to fly in icing, heavy turbulence, and thick mud, conditions that grounded many Allied types and most German aircraft. Even limited night operations were feasible with the addition of flame dampeners and basic instruments. The aircraft's stability under low visibility conditions enabled several pilots to survive nighttime engagements that would have been fatal in more delicate fighters requiring constant, precise control inputs.
These advantages reached their peak during the Rhine crossings in March 1945, when P-47 units flew relentless ground attack missions against entrenched German defenses. Thunderbolts pressed through intense flak, last-ditch Luftwaffe counterattacks, and the fire of portable anti-aircraft weapons. Despite the ferocity of resistance, Allied ground units did not report a single instance in which air support obligations were missed because of P-47 losses. Reflecting on the campaign, Colonel Zemke of the 56th Fighter Group observed that the Thunderbolt effectively redefined the logic of aerial warfare. While speed and agility had traditionally dictated superiority, the P-47 demonstrated that exceptional survivability could outweigh raw performance. American pilots eventually discovered that their aircraft could withstand levels of damage that would have destroyed most opponents and still remain in the fight. That unexpected resilience created a psychological advantage that proved as influential as raw performance. By the final weeks of the war in Europe, the statistics left little room for debate. As of 8 May 1945, the P-47 Thunderbolt had accumulated more combat sorties than any other U.S. fighter type. It released more ordnance on enemy positions, unleashed more rockets, and eliminated more vehicles, artillery emplacements, and ground assets than any of its contemporaries. Yet its greatest achievement was neither firepower nor speed. It was the astonishing number of aviators it returned safely, despite absorbing damage that, by the standards of the era, should have been fatal. Even experienced German pilots recognized this. Adolf Galland, one of the most respected Luftwaffe aces, later acknowledged that although several Allied fighters surpassed the P-47 in specific performance categories, none inspired the same apprehension among German air crews. The Spitfire excelled in tight turns, the P-51 offered unmatched reach, and the P-38 provided superb cockpit visibility. But the Thunderbolt, he said, was the one the Luftwaffe most dreaded. It seemed to resist destruction itself, a trait Allied airmen summed up in a single phrase, the one that wouldn't break. In the end, that nearly indestructible character shaped the outcome as much as tactical doctrine or numerical strength. The fighter's final operational mission in the European theater took place on 7 May 1945. Fittingly, the aircraft came home riddled with damage, 23 punctures from German flak, but the pilot climbed out without a scratch. Had the war continued, the machine could have been repaired and sent back into service within hours. The episode served as a closing illustration of what had astonished Luftwaffe veterans throughout the conflict: the P-47's uncanny ability to endure punishment far beyond what engineers of the time believed survivable. That legacy did not end with the war's close. The lessons drawn from Thunderbolt operations permeated post-war design philosophies, training programs, and technical manuals. Modern military aircraft still reflect ideas forged in those years: redundant critical systems, structures intentionally designed to tolerate significant damage, armor placed to protect the pilot and vital machinery, and conservative engineering margins that favor survival over minimal weight. These principles, refined but unmistakably inherited, continue safeguarding aviators around the world.
Viewed from a broader perspective, the Thunderbolt represented more than a well-engineered machine. It embodied a distinctly American industrial approach: build ruggedly, innovate aggressively, and accept the cost of strength if it means preserving the lives of trained personnel. It demonstrated that technological robustness could shift the balance of aerial warfare as decisively as speed or maneuverability. Crucially, it proved that prioritizing pilot survivability was not merely compassionate, it was strategically indispensable. German pilots interviewed in the years after the war repeatedly described their disbelief when Thunderbolts kept flying after sustaining damage that, in their own experience, would have torn a fighter apart. Many recounted encounters in which P-47s, trailing smoke or shedding panels, nonetheless remained combat effective. That spectacle, an opponent seemingly immune to destruction, had a profound psychological effect. It eroded confidence, strained morale, and contributed subtly but steadily to the Luftwaffe's decline. The numbers alone were remarkable, yet they told only part of the story. Behind each statistic stood a pilot who lived because his aircraft absorbed punishment on his behalf. Families were reunited, children grew up with fathers who might otherwise have been lost, and communities welcomed home veterans whose survival owed much to the Thunderbolt's engineering. In the brutal arithmetic of air combat, the P-47 proved that endurance could be as decisive as firepower. To many German aviators, the Thunderbolt appeared to defy the basic physics of flight. It soaked up rounds that should have destroyed its control surfaces, ruptured fuel tanks, or compromised its structure, and then continued pressing the attack. That capacity to endure, to return home, and to keep its crews fighting until victory was secured became the hallmark of the Republic P-47 Thunderbolt. Its legacy was written not only in sorties flown or targets destroyed, but in the countless airmen it protected. Where other fighters were praised for elegance, speed, or agility, the P-47 was celebrated for something more elemental, its refusal to die. Across Europe and the Pacific, it carved a reputation forged from steel, armor, and American determination, ultimately earning its place in history as the fighter that survived.